again expansion of the well and finding the probability. I hope you can do that one. Question number 16, half harmonic oscillator. I hope you know that one. Only odd states are allowed, or how to say, not odd state, only states which are 0 at x equal to 0 are allowed. Half harmonic oscillator. 16th one, 16th problem. So, if I draw that v of x as a function of x, okay, as a function of x, so it is infinity here, it is parabolic here, then wave function should be 0 here, am I right, in this part. So, then again only states, again your ground state was like this, do you remember, harmonic oscillator. First excited state was like this, what is this one? First excited state was 0 when x equal to 0. So, that is why first excited state is allowed. Similarly, ground first second state is not allowed. Is that okay? Next state is allowed, like that. Again we found its energy eigenvalue in WKB method, isn't it? In WKB method we found energy eigenvalue also. Which one of the following represent possible ground state wave function of the particle? What is the ground state of this? This is the ground state of actual harmonic oscillator. What is the ground state of this one? This is the minimum possible state allowed, isn't it? That is option B. I think there is small tick over there. Have you seen? It was marked earlier. Look at question number 15. You have to solve without Schrodinger equation. How do you do? Psi of x is equal to a e power minus b x square by 2. He asked what is the wave function, and he said one more thing, v of x equal to 0 at x equal to 0. Remember, maybe some other problem we may need to do that one, but this is known. What is this one? Ground state wave function of harmonic oscillator, then your potential should be harmonic potential, isn't it? So, now equate this one to a e raised to minus m omega by pi h, no, m omega by 2 h bar into x square. Now, b by 2 should be equal to m omega by 2 h bar. Okay? B square. Okay? Are you getting my point? Just compare it with, look at here, or let me write like this. So, psi of x is equal to a e power, you have to remember ground state wave functions, okay? You have to remember wave functions of your particle in a box problem, all wave function, obviously, that's very easy. So, later whatever the difficult situation, you have to remember ground state wave function, they are expecting, is that okay? They will not give always, okay? So, minus m omega by 2 h bar into x square, am I right? So, if this is the wave function, what is your potential? Half m omega square x square, isn't it? This is the potential. Now, if so, psi of x is equal to a e power minus b square x square by 2, is that okay? What is your v of x? That is the question. It's very simple. You can compare and you can write. Is that okay? He is expecting us to use Schrodinger equation, but don't do that like that, because this is a known problem, isn't it? Now, when you compare, b square by 2 should be equal to m omega by 2 h bar. M omega is equal to b square h bar. M omega the whole square is equal to b raised to 4 h bar square. M square omega square is equal to b raised to 4 h bar square. M omega square is equal to b raised to 4 h bar square by Why I have done like this? Because I need m omega square over there. Are you getting my point? That was my target. B raised to 4 h bar square by 2m, because you have two options with the same functionality. Look at the options. Which one of the following is correct? That is what he asked. He could have asked energy also, am I right? What? How do you write energy corresponds to this one? Here it was half h bar omega. How do you write energy here? H bar omega. You need omega, am I right? What is omega? B square h bar divided by. So half h bar into omega b square h bar by m b square h bar square by. Now look at here, that option is not there. He clubbed the question. He asked, are you getting my point? How I have done? Actually, you should have gone for Schrodinger equation to find it. Yeah, isn't it? I was comparing, isn't it? Remember, h bar is universal constant. Okay, so you can place it anywhere. But main thing is, in this one, this b square should be related to somehow to m omega, m and omega. Remember, those are particular situations. Am I right? Mass and omega, those will decide the situation. Omega will decide the situation, not h bar. It's a universal constant. Okay? Observe those facts. You can just solve without going to Schrodinger equation. Are you getting my point? Here in this case, E naught is equal to half h bar omega. I already found this equation. Omega is equal to b square h bar by m. So that's why in this case E naught is equal to b square h bar square by 2m. In this case, v of x equal to half m omega square, half b square b raised to 4 h bar square by m into x square. Look at here, this is the potential, that is the energy. Comparing, think over it. Option h bar square b raised to 4. Yeah, option B. Option B. Energy is not there. This kind of energy is not there in the option. 14th one, normalized eigenfunction and eigenvalues of Hamiltonian is given. Suppose the particle is in this state. If the energy of the particle, now look at here. This cannot be, so this can be done using trigonometry, remember. Are you getting my point? Ultimately, in this kind of question, what is the question? Question number 14, am I right? He has given psi of x is equal to a sin pi x by a, okay, into 1 plus cos pi x by a. Ultimately, what you have to write? You have to write this one as Cn into psi n, am I right? In terms of stationary state, you can do it by trigonometry. Look at here, when you multiply, you got ground state. Is that okay? Balance that one. And when you multiply it here, what would you get? A sine into cos. You can write sine a plus b minus sine a minus b. Are you getting my point? Again, everything can be written in terms of this one, like this, using only trigonometry. Isn't it? Earlier, we have used Fourier analysis, isn't it? To write any function like this, we use Fourier analysis, but here it is not needed. Just like in Griffiths, he asked one question, sine cube pi x by a. Do you remember? You have to write that one in terms of stationary state, isn't it? Now, can I do that one quickly? A into, let me take off a outside, okay? Plus sine pi x by a, cos pi x by a. What is that one? Sine half of sine minus or plus? Other term is 0. Okay. Sine 2 theta formula. I was thinking about sine a plus b a minus b. That's again unnecessary, isn't it? Yeah. Sine 2 theta formula. Look at here. Wait a second. You have to find normalized wave function. Be careful. A into what I do here is I will keep root of 2 by a and I will keep root of a by 2, because whenever you write that linear combination, the individual thing should be normalized wave function. Is that okay? So, plus 1 by 2 root of a by 2 root of 2 by a sine 2 pi x by a. Observe carefully. Now, can I take a into root of a by 2 outside? Root of 2 by a sine pi x by a, ground state, plus half into root of 2 by a sine 2 pi x by a, first excited state. Isn't it? He has given the wave function. That is not necessary anyway, you know that one. Now, you have to dare to take off this term. Are you getting my point? Why? In that problem, I multiplied one extra factor, isn't it? If you have any common factor, just leave that one, because if you keep that one, then also you can normalize unnecessary. The term is unnecessary. Is that okay? If whole wave function is multiplied by a constant, state is not changed. Ultimately, you are going to normalize. Once you normalize, that will be unique wave function. Remember, once you normalize, that will be unique. Even if you keep, try to normalize by keeping that term, but it doesn't make a difference. Okay, you are going to divide by something, it will get cancelled. Now, what is C1? A psi 1 plus a by 2 psi 2. When you know, how do you normalize? Mod square of this one plus mod square of this one should be equal to 1. Isn't it? Mod a square plus mod a square by 4 should be equal to 1. Mod a square 5 by 4, 1 plus 1 by 4, 5 by 4, 5 by 4 is equal to 1, a is equal to check that out. Okay. Now, what is the normalized state? 2 by root 5, no, correct? Something is missing. Plus psi 1 plus 1 by root 5, 1 by 2 get cancelled. That is correct. This is now again see that one. Whether it is normalized, square, normalized. When you add, you will get 1, isn't it? 4 by 5 plus 1 by 5, it is 1. Again check out it. You have to quickly do this one. Then whatever the question you can ask, am I right, on average, whatever they ask, isn't it? The probability, look at this one. If the energy of the particle is measured, the probability to get result h bar square pi square divided by 2m a square. What is that in ground state? He said probability of getting the ground state is equal to x by 100. Find x. What is probability of getting ground state? Mod square of this one. Are you getting my point? Mod square of this one. What is mod square? 4 by 5 is equal to x by 100. 5 on the 80. You put that answer 80. See the question again. Are you getting my point? You should be good at this kind of manipulation, isn't it? Ultimately, you have to write. Remember, when you write like this, these should be individually normalized. Don't forget. So, whenever you manipulate this one, what will you get? You will get only again sine and cos. Look at here, sine and this one. Am I right? This is not wave function. This may be wave function, but not normalized, isn't it? So, with this factor, it is normalized wave function, and that factor will come out. I have thrown off. Why? It's not needed. Any constant you can multiply. Ultimately, you are going to normalize. Speak out. Root of 2 pi a. Okay. Take root of 2 pi. It cannot be like that, isn't it? You will get not 1. Again, I couldn't get original question paper of some. I tried, but I couldn't get original question paper. I think 2018. I couldn't get original question paper. That's why I prefer original question paper. Look at here, isn't it? I tried, but I couldn't get original question paper. You can see what is the original question paper, what is typed one, isn't it? Whenever we take the typed material, that's the same problem. Small mistake, it will cost a lot of time actually. Yeah. Anyway, you should be strong enough to say, yeah, there is a typing mistake. It should be like that. You should have done like that. Is that okay? Yeah. What's the question? Yeah. What is that? Double angle. Yeah, double angle formula. I was thinking. I hope you can do rest of all. Let me try last one. Numerical question. Anyway, in CSR you don't have numerical question. This was, I think, Princeton question. I hope you can collect whatever the MIT Princeton question I had given earlier. Okay, and let me design some multiple choice questions out of it, so that you can practice. Okay, 1 by root n factorial state n. Am I right? N equal to 0 to infinity. Nowhere he said it is normalized. Nowhere he said it is normalized, but he has given like it. It looks like it's very well designed, isn't it? Yeah. Whatever. These n are eigenstate of harmonic oscillator. Okay. Let the expectation value of Hamiltonian is half expectation of h will be half alpha h bar omega. Okay. Half alpha h bar omega. What is the value of alpha? Now, how do you find expectation h actually? Summation over mod c n square into E n, isn't it? That is how you do expectation. But what is this? This is the coefficient when you have normalized that one. No, this is not normalized. Take mod square of the coefficient, add, that is what is that one? 1 by 1 factorial, 1 by 2 factorial. That is not normalized. Is that okay? Now, you have to normalize that one. To normalize, let me keep one constant a, isn't it? That multiplication by a will normalize that one. That is how we think. Am I right? After normalization, I have to go for this one. Then I have to equate that one to half alpha h bar omega. Then I have to find the answer. Okay, little lengthy procedure, but you can do. That's not difficult. Okay. Now look at here. What is normalization condition? Can I write like this? Summation over n equal to 0 to infinity a by root n factorial state n. Am I right? Mod c n square summation over n, that should be equal to 1. Normalization condition, mod c1 square plus mod c2 square and so on, that should be equal to 1. What is cn? Can I take this one as cn? Isn't it? So, that will be summation over n equal to 0 to infinity. So, mod a square divided by n factorial is equal to 1. Mod a square is outside. What would you write? 1 by 0 factorial is 1. Am I right? 1 plus 1 by 1 factorial plus 1 by 0 factorial, 1 by 1 factorial, 1 by 2 factorial plus and so on is equal to 1. What would you write this value? You know that one? You know that one? You know that one? No. Okay, e power 1. Yeah, good. Isn't it? Mod a square is equal to e power 1. E power x is? Yeah, wait. What is e power x expansion? 1 plus x plus, yeah, x square by 2 factorial plus and so on. Yeah, when you put x equal to e power 1 is equal to 1, what is a? 1 by root t. Is that okay? Now look at here. So, what is the normalized wave function? 1 by root t over. So, then you have to go for this one. Now, it is normalized wave function. Can I rewrite? Summation over n equal to 0 to infinity 1 by root e 1 by root n factorial. So, state n, am I right? Now, you can go for this one, you can equate that one to this one, isn't it? Now, how do you write? Is equal to summation over again mod c n square into E n equal to 0 to infinity. Now, that is equal to 1 by root e outside, 1 by root e outside, okay? Anyhow, no, 1 by e outside, okay, 1 by e outside, 1 by 0 factorial into what is e 0 half h bar omega plus 1 by 1 factorial, what is e 1 3 by 2 h bar omega, but you do not know the series. What will you do? Plus 1 by 2 factorial 5 by 2 h bar omega, am I right? Root e is taken, that 1 by e is taken outside. You do not know this series, what will you do? H bar omega can be taken off. Numerical question, gate or just exam, suppose. What will you do at that instant? What will you do? Remember, it also matters, isn't it? It is an exam hall. Who cares whether you know that arithmetic or geometric series or whatever it is? Is it arithmetic or geometric? No, not even arithmetic or geometric series. Take h bar omega outside, is that okay? If I take h bar omega outside, let me write it here, h bar omega by 2 also outside, yeah, by 2 also outside, because here you have, am I right, only alpha is 1 by e into what is that one? 1 by 0 factorial plus 1 by, what is the next term? Just look at that one. Half h bar omega 3, so 3 by 1 factorial plus 5 by 2 factorial plus 7 by plus, speak out, 9 by, what is 5 factorial? Nine by 4 factorial. What is 4 factorial? 24. Look at here, those terms are goes on decreasing. You will have a calculator. Why can't you add this term? And take one more term. 11 by, take one more term, add that one. That is goes on decreasing. It will approach some value. You will get to know what is that approximate value. You have a calculator, again not CSIR question, okay? You have a calculator, just add this term. Why can't you do that one? 3 marks question, I think. It's worth spending time, remember. Yeah, speak out. Am I right? Taken common half, yeah, that's correct. I think this will be too small. Look at it, 5 factorial is 120. Then 11 by 120, that's too small. Look at here. So, next term is still small. You can neglect. And you will get approximate answer. Obviously, they will give some range of answers. Is that okay? So, you can write some approximate answer. So, shall I go to TIFR question? Which one? Which one? Which one 2n plus? Which one? Oh, okay, he is talking about energy. I think then also you will not get the summation of the series, am I right? Ultimately, then you have to equate to that h bar omega by 2 into alpha. I think he was remembering En is equal to like that. Yeah, that's also okay. 2n plus 1. We have written 1, 3, 5. Same thing. Okay, whatever formula you use, You will get into same trouble. Is that okay? You will get into same trouble. This summation is not now. Is that okay? Don't leave that one. Okay. You should not accept what you call failure. Are you getting my point? Shall I go for TIFR question quickly? Again, watch video lectures if you need any theory again. Okay. Where is that? TIFR. Yeah, this very first question, that is Griffith's question, am I right? The ground state wave function is that one, A is constant. If suddenly the parameter k is changed to 4k, I told why they would make k to 4k, so that omega becomes 2 omega. Omega is equal to root of k by m, isn't it? Omega will be doubled, so that you can take that. Now look at here, in this particular problem, either you can take whatever they have given, or you can take your own wave functions actually. Anyway, you are going to remember ground state wave function. Look at it, if you remember their wave function, you need to normalize that one, isn't it? You need to normalize that one. Why? He hasn't given normalized one, he has given only proportionality. Look at the very first question, he has given v of x is equal to half kx square, and he has given psi of x ground state, that is proportional to e raised to minus a x square by root k. Now, you need to normalize this one. Why would you take that step? Am I right? Are you getting my point? You have to normalize this one. You can do that one. Normalization is not a big deal, isn't it? But what I feel is, I know v of x is equal to half m omega square x square. I know wave function is equal to m omega by pi h bar raised to 1 by 4 e raised to minus m omega by 2 h bar x square. I should know that one. Huh? Okay, ax square into root k, not by root k. Yeah, both will work. It will work. Okay, you can take that one. If k is quadrupled, then omega will be doubled. Omega is equal to root of k by m. Mass will be constant. If k is 4 times, omega will be doubled. Am I right? So now this is your initial wave function. What is your final wave function? Final ground state wave function when omega is doubled. E raised to minus 2m omega by 2 h bar x square, isn't it? This is your final state. It is also normalized. Omega is changed by 2 omega. It is also normalized. No need to worry. In that place, I put 2 omega. That's it. That's also normalized. Now look at it. You can take inner product, because while taking inner product, those are individually normalized. Those should be individually normalized, isn't it? Born interpretation, initial state into final state. What did he ask? Probability of getting ground state, am I right? This is ground state of new harmonic oscillator when omega is doubled. You can use this one. Root k is equal to m omega, root m omega. Okay. If you put k here, k is root k the whole square, that becomes again m omega square, half m omega square x square. But when I normalize, You got small question here. When you normalize this one, how do you get h bar? You will not get h bar. Yeah, no, you have to keep A as it is. You will get something here. You have to proceed with that one. Yeah, you can do. You can do that one. You will get the same answer in both cases. Okay, I was just checking that one. Can you do in both way? In that case, do in this way. Find the answer. Again, normalize this one. What is this normalization? Any idea? Root of pi by coefficient of x square. Am I right? That was 2a by root k and mod square raised to 1 by 4 e raised to minus ax square not 2a root k. I hope this is the normalized state. Just check it out. I hope you remember this one, minus infinity to plus infinity e power minus some ax square dx. What is this one? Root of pi by coefficient of x square. Okay, shall I list out? What are the other integral that you need to remember? 0 to infinity x raised to n e power minus ax square dx. What is this one? E power ax square 1 by 2 into a power n plus 1 whole divided by 2 gamma of n plus 1 whole divided by 2, where gamma of n is equal to n minus 1 gamma n minus 1. You should know this property. Gamma of half is equal to root pi. One more very basic gamma function is 0 to infinity x raised to n e power minus ax dx. Am I right? That was equal to gamma of n plus 1 divided by a power n plus 1. Gamma of n plus 1 is n factorial. If n plus 1 is integer, it is n factorial. If it is half integer, you have to reduce. I hope you practice that one. N factorial divided by a power n plus 1. I hope you remember this. Okay, apply this one, do in both cases and show that both are same. Then you will get some confidence to use those methods, isn't it? Are you getting my point? So that is the main advantage in doing the problem in a different way. Don't forget to make mod square, okay? Are you getting my point? What is the probability of getting this one? Probability of getting this one? Star. You are doing the measurement on this one, you are finding what is the probability of this one. When you suddenly change k to 4k, this will be momentarily unchanged. You are doing the measurement on this one, you are trying to find this one. Is that okay? Again, what is the limit? What is the limit? What is the limit? Limit is minus infinity to plus infinity. Remember, range of this wave function and this wave function both are minus infinity to plus infinity, Gaussian. It was in particularly in a box problem, we had change of limit, am I right? Earlier wave function was minus L by 2 to plus L by 2, new was minus L to plus L, am I right? But here both wave function range is minus infinity to plus infinity. Is that clear? You can do this problem. Wait a second, I forgot one more formula here. What was that? E power minus ax square plus bx plus c. It was there in Griffiths. (4a) or 2a? 4a. Over? Second problem. Any problem? Which one? Anyway, you have to remember this one. Is that okay? You have to remember this ground state wave function. That's what I am expecting. Ground state wave function of harmonic oscillator, ground state wave function of Dirac function, well, only one state. Dirac function, well, it has only one state. Is that okay? Okay, that is the ground state. Is that okay? Then ground state wave function of hydrogen atom, okay? You should remember them because they are expecting like that. And that is very helpful, okay? That's very helpful. Again, that's what I have used this one only, this integral only. This integral should be used to find this normalization, am I right? Normalization factor. Yeah, what he is saying? Which trick? This integral trick? Or any other? Again, remember, it will not take much time. So I can give trick for all particular problem individually. Then how many trick will be there? Don't go for that one. Do some mathematics. It will, how much time it will take, isn't it? You have to rearrange this term, isn't it? Are you getting my point? It will not take much time. Is that okay? It will not take much time. Again, this will be this kind of integral, isn't it? Root of pi by coefficient of that one. Coefficient will be cancelled. Again, it is problem from Griffiths, okay? Soon after harmonic oscillator, he mentioned this problem. Is that okay? And remember these integrals, okay? These integrals. So, one, then second. This is needed for your Fourier transform. I hope you experienced that one, am I right? For Fourier transform question, that is needed. Okay, this is the also most general one, and this is gamma function definition. Okay, sometimes they in the TIFR exam you can see, yeah, this question number 3. Look at that one. He directly asked what is that integral. Okay, you need that one. Okay, you need that one. I mean, they are expecting like that. Okay, they may ask that integral directly sometimes. Okay, yeah, try to work it out. Okay. I think you can answer question number 2. What is that wave function? Look at that wave function carefully. Yeah. Look at that wave function. E power minus k mod x. What is that wave function? Dirac function well. That's it. Just choose the Dirac function well. Yeah, only one Dirac delta in the option. He would have given one positive Dirac delta, other negative Dirac delta, isn't it? Obviously, Dirac function well contains one bound state, but Dirac delta barrier will not contain any bound state. It is a purely scattering state. Are you getting my point? I hope you have solved that one, isn't it? Energy eigenvalue. Now look at here. If you have remembered that wave function of Dirac function well, then this question is nothing. Am I right? Some a e raised to minus k mod x, isn't it? It is of this form. Is that okay? Now look at here. He may be expecting us to go for Schrodinger equation. Why would you do that one? We already, it was very well studied that one. Am I right? For this kind of potential, what is that one? Minus alpha delta of x or minus v naught delta of x, like that. Alpha is positive, isn't it? You should know that one. Okay, you should know that. Yeah, very next question, integral. That is exactly this integral. Am I right? That's why look at here, 0 to infinity. Don't think like it is odd function. Don't make it 0. Yeah, you are very lucky. There is no 0 option. The limit is not symmetrical. Look at the question. Okay, limit is not symmetrical. So limit is 0 to infinity. 0 to infinity. Can you quickly do this one so that you can apply this one? X raised to 9 e raised to minus x square dx 1 by 2 into a is 1 raised to n plus 1 by 2, 9 plus 1 whole divided to 5, whatever. So gamma of phi. Gamma of phi is 4 factorial. Gamma of phi by 2 you have to reduce that one, isn't it? 4 factorial. What is this one? 12. Is that okay? Fourth one. Yeah, I am expecting you to do this much step, okay? This much step. You need to do this one. You need to practice this one. That's why I feel this is the most general one. Why? Because look at here. If I had given x raised to 4 into e raised to minus x square dx from minus infinity to plus infinity, what would you do? 2 times 0 to infinity, again it will be converted into this one. That is why this is the most general one. Is that okay? This is the most general one. That is why I had given that one. Is that clear? Are you getting my point? Suppose x cube, what is this one? 0, odd function. Limit is symmetrical. Is that okay? That is why all of those integral can be converted into 1, 2, 3, 4. 4 type of this integral. Whatever the infinite integral it comes, even in hydrogen atom also, usually. Is that okay? Yeah, practice that one. I hope you remember this one. Suppose gamma of 5 by 2 comes here. Then what you have to do? N minus 1, gamma n minus 1. 3 by 2, gamma 3 by 2. Is that okay? So then 3 by 2. What is gamma of 3 by 2? N minus gamma n minus 1. 1 by 2, gamma 1 by 2. Is that okay? That is equal to 3 by 4. What is gamma of 1 by 2? Root 5. Okay? I hope you can reduce that one. If you have gamma of any integer, suppose 5, you can quickly write 4 factorial. But gamma of half integer, you have to successively reduce according to the rule gamma of n is equal to n minus 1 gamma n minus 1. This is the most general rule. If it is integer, you can write n minus 1 factorial. Okay? Just practice. Yeah, what he is talking about? Any idea? Integral technique? No, I think they will not ask nth state here. Okay, he is thinking about probability of getting nth state, isn't it? Let me tell you why they will not ask nth state. Because your nth state will be Hermite polynomial is going to play the role. That wave function is too difficult. Is that okay? So they are designing questions so that it is doable in most of the case. Okay, most of the problem, even in CSIR. So just get in all exam. They will design the question so that it is doable. At the most, they can give first exact state. What is that first exact state? X into Gaussian. At the most, they can give first exact state. They will not give nth state actually. Is that okay? Any other possible way if they give nth state? No, you can't use your ladder operator also. No. That would be too difficult. Is that okay? That is why they will design questions so that it is doable by this kind of integral. And sometimes in this exam, they will mention this integral. Is that okay? They will mention those integral along with that question. They will mention that integral also, so that you can make use of this integral. Okay? They will expect you to know that this concept. What is the concept? You have initial wave function. You are doing the measurement. Probability of getting the final wave function, probability amplitude mod square. They expect you to know that concept, that is it. Okay? So try to apply that one. Fourth one, quickly. It is R is equal to expectation A square minus expectation A square. Sorry, expectation A the whole square, expectation A square. Do you remember what is our sigma A? This was standard deviation. Standard deviation can never be imaginary. It will talk about width of the distribution, isn't it? Width of the distribution imaginary is meaningless, remember. Width of the distribution can never be negative also, obviously. The minimum width is 0, isn't it? So that is why this whole quantity should be positive. So that it should be real always. If this is positive, this should be negative, am I right? It is ulta. That is it. R is less than 0. Are you getting my point? Standard deviation formula. Speak out. He has given ulta. This is under root, am I right? This quantity should be positive. If that is negative, it will be negative. You heard whenever any situation where standard deviation is imaginary, yeah, it can be equal to 0 or it should be greater than 0, isn't it? It should have given less than or equal to 0. It can be 0. Option A. What he has given? Option A. No, whatever, that is true, am I right? We can take standard deviation in any state. If it is eigenstate, it is 0. Yeah, he said, yeah. Now, why he hasn't given 0? If it is eigenstate, standard deviation is 0. Why this will be equal to this one? Are you getting my point? If it is eigenstate, it is 0. He said it is not an eigenstate. That's why these two, this is non-zero, obviously. Are you getting my point? Wait a second. Question number 4. He said it's not eigenstate. If it is eigenstate, let me take like that. If it is eigenstate, let me take ulta. Okay, A is this one. A square psi is equal to A scalar. Okay, A square psi. Then expectation A is equal to A. Expectation A square is equal to. Check that out. Isn't it? Take inner product with psi, you will get expectation A. Take inner product with psi, you will get expectation A square. Are you getting my point? So, then look at here, square this one and subtract this one. What is this sigma A? If psi is eigenstate of A, your standard deviation is 0. Am I right? Your energy eigenstates are eigenstate with energy, what do you call, standard deviation is 0. Are you getting my point? What is sigma h? Suppose if you have taken psi n with known eigenvalue E n. What is your sigma h? It was 0. We have shown again read out that one. Second chapter. Okay, Griffith's second chapter. Same thing will happen. This is in case of energy eigenstate. Here he has given arbitrary operator. The same thing will work. Am I right? Later we generalize that one. Initially we have done everything for energy eigenstate. Later I generalize the theory, isn't it? For any operator, that is true. So, that is why he said it is not an eigenstate. That is why this will never happen. This will never happen. If it doesn't happen, if it is not happening, then expectation A square should be greater than expectation A the whole square. Why this should be? This should never be imaginary. That is why inside the bracket should be positive. So, if this happens, obviously R is less than 0. All are designed question. Okay, so that's why there will be not much mistake here. Yeah, I think next question, fifth one. A particle of energy moves in one dimension under the influence of potential V of x. If E is greater than V of x for some range of x, which of the following graph represents the bound state wave function? Yeah, look at options. Option A is he said bound state. Bound state should be normalizable. Is that okay? Scattering state need not be. Scattering state is usually not normalizable. Go for option A, that is normalizable. Option B, normalizable. Option D, can you find any problem with option D? Discontinuous. Wave function will never be discontinuous. Option A is normalizable. Option C cannot be normalizable. C cannot happen to be C and D. Just rule out C and D. Now, the question is between A and B. Now, how do you choose between A and B? How do you choose A and B? Either A or B. How do you choose between A and B? Now, look at here. He said E is less than V. A bound state means E should be less than V of x in both sides. Griffith's second chapter, bound state and scattering state. Jetili fourth chapter, bound state and scattering state. Read out very carefully. Look at here. It's a very logical question, isn't it? If E is less than V of x in both sides, then there should be bound state. Are you getting my point? Isn't it? Suppose you have some potential, is that okay? If your energy is like this, then it is scattering state. Am I right? If your energy is like this, it should be bound state. Bound state means it cannot escape in any side, am I right? I defined like that. Now look at here, in this non-classical region, your wave function should decay. Go for WKP. We argued like that. In the non-classical region, it was exponentially decaying type, isn't it? WKP solution also said like that, or even if you solve Schrodinger equation, it will also give the same thing, exponentially decaying solution. Is that okay? Here your wave function cannot be oscillatory. Now option C, option C, that contains a kind of oscillatory thing, isn't it? That cannot happen. Oscillatory wave function happens only when it is free, only when it is in classical region. Is that okay? This is the region where E less than V of x. Energy is less than V of x, non-classical region. Non-classical region. Look at here, this is classical region. That's why here your wave function should be decaying. E power minus kx kind of thing, usually. Okay? That's why option A. Yeah, what's the option? Correct option? Option B. For some range of option C, A, option A is the correct one. He said bound state. Look at here, you got distracted. You got distracted by saying E is greater than V of x. Read the question again. Later he said for some range E is greater than V of x. Now let me assume my potential like this. Okay? Let me assume my potential like this. I have potential like this, suppose. Now if I have energy, for some range energy is greater than V of x, isn't it? But he said bound state, that means outside that range energy is less than V of x, that is non-classical region, there your wave function should be exponentially decaying in non-classical region, isn't it? We have solved many questions on that one, our scattering problems like that, where non-classical region it was exponentially decaying. I think I have uploaded some images also, isn't it? Can you just upload those images? No, not that one. So can you upload some questions, some images from any book? I mean, like that in different case, how wave function looks. There are questions in GATE exam, isn't it? Yeah, like that. Okay, upload that kind of images. So not from this book. I think from Jatili and other book. Okay. Seventh question, again you need that integral. Seventh question. That was first excited state of harmonic oscillator, kind of thing, x into Gaussian. That's what I think. You need to normalize, then you have to go for, wait a second, he said expectation of P. Yeah, anyway, you have to do that one. I was thinking of going to momentum space, but that's too difficult. Okay, no, don't think anything else. Just do an ordinary method. Okay, you have wave function first normalize. Without normalization, if you find expectation value, that will be wrong. Okay, expectation of P cap. How do you write? That's it. Your range is minus infinity to plus infinity. If he hasn't mentioned any, if he is not mentioning any range, take minus infinity to plus infinity. Obviously, in this region, your wave function, whatever he has given, x square by lambda. Yeah, this is normalizable because this was first excited state of harmonic oscillator. Now, he said it is unnormalized, you normalize it. Okay? Normalize this one and substitute here, do it in ordinary way. I don't think any trick here. Wait a second. Expectation P should be 0, am I right? You have 0 option. Yeah, is that answer? Why? Why 0? Expectation P. You don't have expectation x. You have to take derivative. How do you know after taking derivative that would be odd? 0. 0? Yeah, why it is 0? Stationary state. It was a stationary state. It was the first excited state of harmonic oscillator. There also, if you want to find expectation P, you have the same idea, am I right? Are you getting my point? There also, you will get the same integral. That mathematics is same there and here. Are you getting my point? Mathematics will not take different thing. Only symbols are changed. That's it. This was a stationary state. So here expectation x was 0. Again expectation P. You can relate that one to expectation x by that was 0. Look at here. No need to solve sometimes if you know that enough concept. Are you getting my idea? There also you got the same step, am I right? Suppose if you are writing psi of x comma t, suppose x comma t by switching your e power minus I e t by h bar, then also whenever you do psi star into psi, that time parameter will not come into play the role actually. Is that okay? Whatever, psi of x, let it be. Or if you do that one, you will get that one. You will get ultimately odd function even after taking the derivative. Taking the derivative, you will get total wave function odd, you will get 0. Yeah, speak out. What did he said? Why not P is derivative? He said momentum. Yeah, he said momentum, expectation P. Why you are not thinking it is a derivative? Why? You are not in momentum space. Yeah, he went for momentum space. Position space, isn't it? But I am saying, yeah, you will ultimately get odd function, you will get it 0, but you will get the same mathematics over there also, am I right? While finding expectation P, m into d expectation x by dt. Yeah, speak out. Okay? Or do that one, it will not take much time. If you are not feeling comfortable, do that one, it will not take much time. Taking one derivative of this one, isn't it? Later find A, just keep that A outside, later find A, isn't it? If it is 0, you don't have to find A, isn't it? Yeah. Be lazy for a while, okay? Because you don't have much time. I think question number 8 you need to substitute into, yeah, let me try question number 8 without solving. You have to substitute it into Schrodinger equation. He has given V of x is equal to k x power beta k is greater than 0 option A, lambda is equal to beta by 2 plus 1. Where is lambda? Yeah, wave function was equal to e power minus x power lambda let me try, okay. You have to go for Schrodinger equation actually to find these relations. Is that okay? But you have any known problem? Yeah, you have two known problems. One is hydrogen atom, other one is harmonic oscillator. Is that okay? Now, if beta is equal to 2, that becomes harmonic potential. Then lambda is equal to, that should be Gaussian. Are you getting my point? In this kind of generalized question, so take some known fact, try to apply that one. You may able to eliminate the options. You may, okay, I am not sure. And it happens most of the case. Are you getting my point? Now look at here. when beta is equal to 2, lambda should be 2. I think in all option. Where it will not happen? Here it will not happen. When beta equal to lambda in all option. Yeah, he is very careful on that one. What I think is I can apply if beta is equal to -1, lambda is equal to 1. Wait a second, I am not sure because there it was 3-dimensional problem. I mean V of x equal to 1 by x, 1 by r potential, your what do you call Coulombic potential. Then your ground state wave function was e power minus r kind of thing. Let me try that out. Beta equal to -1, lambda should be equal to 1. No option satisfies. Then that interpretation is wrong. No option satisfies that one. Check it out. Yeah, then that interpretation is wrong. Yeah, you have to go for Schrodinger equation. Can you do this one? A little lengthy, but you can try. Don't apply that one because hydrogen atom problem was 3-dimensional problem. Here it is 1 dimension, but you can apply this one. You can apply this one. Why? That was also 1-dimensional problem, isn't it? You can apply with confidence. Yeah, better to close it here. Yeah, lot of questions are there. Again, try them. Finish out today. Okay. If you got any difficulty, quickly post that one into Facebook. Let me answer. Yeah. Any question? Yeah, but keep this method in mind. Okay. There are many CSI questions, generalized question. You can apply whatever you know, known thing, known problem, and you can eliminate the options. Okay. Keep this one in mind, but here you can't do. He was very careful. Otherwise, it was almost done, isn't it? Yeah. So that's why if question is designed, they will be very care enough to design the options also. Is that okay? If question is not designed, then you can explore those techniques. Okay? Yeah, we shall see in the evening. Yeah, wait a second. So, finish out that one. Okay? Griffith's first 2 chapter, and then Griffith's first two chapter, and then Jatili first and 4th chapter. In Jatili first chapter, solve that phase velocity, group velocity problem today. Is that okay? Phase velocity and group velocity problem. So it came in our free particle theory. So relation between them, and there is one example solved problem that I suggested, isn't it? Solve that one today. Okay. I think apart from that one, you don't have to worry much about Compton effect, photolytic effect. Just go through that one because there are no questions on that one. Okay, Compton effect and photolytic effect. But study that 4th chapter, 1-dimensional problem properly. Is that okay? Along with Griffith's first and 2nd chapter. In 2nd chapter, you have particle in a box, harmonic oscillator, Dirac function well, scattering problems, isn't it? Finding number of bound state problem, finite depth of the well, like that. Okay, just finish out them so thoroughly. Is that okay? So don't do any derivations. Don't think of doing any derivation. Is that okay? So just finish out within 2 to 3 hours. Okay, quickly.